This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Did you know that you can take the derivative of a derivative? Let's learn how it works. Given a function y equals f of x, we can take the derivative, which we commonly write as f prime of x, or dy over dx. We can then take the derivative of f prime, which we'll write as f double prime, or like this. This is known as the second derivative of f, and can tell us a lot of useful things about the original function, like its intervals of concavity and inflection points. But why stop there? You can also find the third, fourth, or any nth derivative by continuing to differentiate that many times using the standard rules of differentiation. Let's get some practice with finding higher derivatives of polynomials. What is the second derivative of negative 3x squared? Well, if we want to find the second derivative, we should start by finding the first derivative. This is a polynomial function, so we can apply the power rule, which tells us to multiply the coefficient by the exponent of x, and then decrease the exponent of x by 1. In this case, we'll multiply negative 3 by 2, and then change the exponent to 1. Simplifying, f prime equals negative 6x. To find f double prime, we'll just take the derivative of f prime, using the power rule again. Negative 6 times 1 is still negative 6, and x to the 0th power is just 1. So, the second derivative equals negative 6. Let's find the second derivative of 4x squared plus 7x minus 9. Starting with the first derivative, we can find it by taking the derivative of each term. Applying the power rule, the derivative of 4x squared is 8x, the derivative of 7x is 7, and the derivative of 9 is 0. Now we can take the derivative of 8x plus 7 to find our second derivative. The derivative of 8x is 8, and the derivative of 7 is 0, which add together to give us a second derivative of 8. Great job! This time we'll try finding the third derivative, but we'll still start the same way, by differentiating x to the 8th power minus 4x to the 5th power plus x squared. The first derivative equals 8 times x to the 7th minus 20x to the 4th plus 2x. The second derivative equals 56 times x to the 6th power minus 80x cubed plus 2. Now we can find the third derivative by taking one more derivative. We get 336 x to the 5th power minus 240 x squared. Let's try one more together. How can we find the fourth derivative of negative 2x to the 6th plus 8x to the 4th? Let's differentiate it 4 times. The first derivative of negative 2x to the 6th plus 8x to the 4th is negative 12x to the 5th plus 32x cubed. The second derivative is negative 60x to the 4th plus 96x squared. The third derivative is negative 240x cubed plus 192x. And so, the fourth derivative is negative 720x squared plus 192. Nice work. There's a really nice pattern with higher derivatives of polynomials. Let's look at all the derivatives we found. The first function has degree 2, and its second derivative is just a constant, so it has degree 0. That's also true of this one. This function has degree 8, and the third derivative has degree 5. And our last example had degree 6, with a fourth derivative of degree 2. Do you notice the pattern? The degree of a polynomial function's nth derivative will be the original function's degree minus n, unless this difference is negative. Then the degree of the derivative will just be 0, since we know polynomials can't have a negative degree. You can use this to check your work when practicing derivatives on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.